Good evening and welcome to Virtual Climate Science on Tap. Tonight's event, What to Expect When You're Expecting Climate Change, is a co-production of the City of West Palm Beach Office of Sustainability and the University of Florida's Thompson Earth Systems Institute. We're going to talk about a heavy topic today, but I promise we will leave you with a message of hope, so stick around until the end. Before we go on, I just want to give a few introductions. I'm Elaine Christian. I'm a Sustainability Program Coordinator with the City of West Palm Beach Office of Sustainability. The City of West Palm Beach has been committed to sustainability targeting climate change for over a decade. We were one of the first cities in the state of Florida to have a dedicated office addressing climate change, sustainability, and resiliency issues. The Office of Sustainability collaborates with various city agencies, nonprofit organizations, businesses, and private citizens, among others, to enhance the viability of the municipality as a model of healthy, environmentally progressive, resilient, and ecologically sustainable urban living. To this end, we have developed a net zero 2050 community-wide greenhouse gas emission goal, which means we are targeting net zero greenhouse gas emissions within our city through decreased and offsetting emissions by the year 2050. But we can't do this alone. City operations only account for a very small percentage of the city's greenhouse gas emissions. The only way we can reach this goal is by actively working together holistically with all of you, our community residents, businesses, schools, and all of our city departments through education, such as this event and the Climate Science on Tap series, outreach, and implementing new initiatives. I encourage you all to visit our webpage, WPB Green. You can sign up for our newsletter on that page, and I also encourage you to visit our social media pages too. WPB Green on Facebook, Instagram, and Twitter for more information on the various programs and free resources that we offer. As I mentioned before, we work with all city departments, and we are partnering with economic development to bring this Climate Science on Tap series to you. So now I'm going to hand it off to the Director of Economic Development, Chris Rug. Chris?
Good evening, everybody, and thanks, Elaine. Thanks so much, and thank you all for joining us tonight. As Elaine mentioned, we partner the Department of Economic Development partners with sustainability on several initiatives because without a healthy planet, our economy would definitely be less robust for sure. So. This series is really a great initiative where we're partnering with our local breweries and distillery industry, which has been growing at quite a rapid pace with these craft businesses opening up, and has actually got the city to rethink about some of our targeted industries, and has started a boutique manufacturing criteria for targeted industries as a result. So definitely want you to go out, support those local craft breweries and distilleries in our community. And tonight, happy to highlight Steel Tie Spirits that has gracefully partnered with us tonight. So thanks so much, Elaine, and enjoy tonight's great presentation.
Thank you, Chris. And so now I'm going to hand it over to John Moore. He is actually at the distillery with Steel Tie Spirits.
Good evening, everybody. Thanks to Chris and John Morales for being here. I can't wait to hear you talk. Thanks to the whole team for letting us be a part of this. For those who don't know, Steel Tie Spirits is your local distillery. We're located in the downtown West Palm Beach Old Warehouse District, in the same block where the Grandview Market is. The first thing we want to hit on just very briefly is the science of distilling. We are talking about climate science, and therefore it's worth mentioning that breweries, wineries, distilleries, cideries, it isn't a huge amount, but in the course of creating alcohol, the process of fermentation does release a little bit of CO2. That's where beer and wine and ciders get their bubbles, but most wineries allow it to escape into the environment. It's a pretty big movement these days in a lot of circles, especially international distilling circles, where we're now starting to work on trying to capture that CO2, and we here at Steel Tie are working on a technology of our own to pipe that CO2 off the top of our fermentation tanks behind me and bring that up to a greenhouse that we intend to build on our roof. What we would do with that is use that CO2 to further the healthy growth of the botanicals that will go in the gin that we're developing, and see what we can do to do some good local agriculture just not only to do our part for our local community, but for the global atmosphere. You've probably seen online any number of stories on Facebook or Instagram or whatever, neighborhoods in Brooklyn and other parts of the country where they're using big shipping containers to grow just organic agriculture and lettuce and whatever things to feed the neighborhood. And that's something that the family that I work for and I are very passionate about trying to do. We had that in our sights for the first half of this year. Obviously, we saw a little bit of a hiccup with this whole COVID situation, so stay tuned for that. And the other thing that we had to adjust for in the course of this whole COVID conversation was we were able to start actually using the spirits for what would have been our vodka or our rum to make hand sanitizer. It's been a great honor for us to be able to provide that free of charge to our local first responders. It is for sale for totally very reasonable prices, $8 for one of these. And that $8 allows us not only to hire out-of-work bartenders to help us bottle and package it, but it also allows us to donate it for free to the first responders, the fire department, the police departments of all the municipalities around here, just to keep the community safe. And it's been really, really great for us to be able to do that. If you get a hold of it, first batch that we had smelled just like rum. Wonder why. The second batch we did, most of it smells like corn whiskey. We do use a little bit of corn distillate in our vodka blend, and we moved into corn distillate because it's a much less expensive product and allowed us to bring the cost of selling and producing the sanitizer down to a much more reasonable level than it was at the very beginning when everything was impossible to get a hold of. But anyway, that's really the jam right here. If you feel like you'd like to know more, we highly encourage you to find us on our Facebook page, our Instagram page at Steel Tie Spirits, or better yet, just come by the distillery. We're open Thursday through Sunday from noon to 7 p.m. and we'd love to see you and give you samples of everything and tell you all about who we are and what we do within the community. And I think that's kind of it for me.
Thank you so much, John. And before we go on, I just want to mention to everyone who is attending today, we are going to have a trivia at the end, and we'll be giving away gift cards to Steel Tie Spirits, so stick around.
Thanks so much, Elaine. I wanted to tell you a little bit about Thompson Earth Systems Institute, or TESI, which is located at the University of Florida's Gainesville campus. Our mission is to advance communication and education of Earth systems science in a way that inspires Floridians to be effective stewards of our planet. What are Earth systems, you ask? It's the interactions between air, land, water, and life, and how we influence those. We do this through three main program areas. One is the Scientist in Every Florida School program that aims to build long-term relationships between teachers and scientists in order to inspire the next generation of environmental stewards. Our team of trained communicators and educators also put on public programs much like this event and produce digital content to help people engage in science in meaningful ways. And lastly, we help both scientists and journalists hone their communication skills through our science communication professional development programs. Our mission is really to lead the way to a healthier planet by cultivating a responsible and curious society that both values, trusts, and has access to science. We also want to encourage you to sign up for the Earth to Florida newsletter. It's a monthly bulletin that's curated around the state's environmental news and explains what's going on, why it matters, and what you can do about it. If this sounds like something that piques your interest, you can find a link to subscribe in the top of the chat box tonight. We also want to tell you where you can learn some fun facts about Florida's natural history, its animals and plants. And you can do so by following our Instagram account at Know Your Florida to impress your friends and maybe learn a little bit new Florida knowledge. And finally, we would like to tell you that you can keep in touch with us and our friends at the Florida Museum by following our social media at UF Earth Systems on both Facebook and Twitter. We are so excited to be partnering with the city to kick off this new Climate Science on Tap series, and we are equally excited to introduce our first speaker tonight. Tonight, we are bringing you award-winning meteorologist John Morales from NBC6 in Miami. Born in New York and raised in Puerto Rico, he attended the meteorology program at Cornell University and was then hired by the National Weather Service in 1984. In 1991, he was hired by the Spanish language television network Univision, and he also founded a company called Climate Data Corporation. He has won 3 Emmys and has a seal of approval from both the American Meteorological Society as well as the National Weather Association. Before we turn things over to John, we want to go over a few more housekeeping items with you that you'll be able to reference at your convenience in tonight's chat box by flipping up to the top of the chat. Be sure you have your beverage and your snacks on hand, of course. We ask that you write any questions for John in the chat box, and we'll get to those questions a little later this evening. If you need to move the Zoom presenters boxes on your screen, you can do so by clicking and dragging them. Be sure to pay close attention because, as Elaine said, we are having a live Kahoot trivia game tonight in which you can participate to win big. If you want to play that, you want to be sure that you have your cell phone handy because you're going to need that to play. Finally, for our Facebook Live audience, if you would like to participate in the trivia game, please be sure to use the Zoom registration. We'll post that link in the comments box on Facebook for you to join in with us. And finally, we encourage you to take a moment at the end of tonight's Climate Science on Tap to fill out the survey to let us know about your experience. So now I'd like to find out, as I'm sure you do too, what to expect when you're expecting climate change. John.
Hi, everybody. Great to be here. I appreciate the invitation, and I am going to attempt to share my screen. And as soon as I can figure that one out, I think you will all be seeing, let's see here, my presentation, or so I hope. Okay, I assume you've got a screen that says what's ahead, perhaps? Yes? Somebody?
Yes.
Yes, thank you very much. All right, so let's talk about what's ahead and what some of the challenges are. And yes, indeed, we are going to finish with a bit of a hopeful message here at the end. You already heard a little bit about me. I guess I'll add one more thing. I am 2/3 of the way through a master's in environmental science and policy at Johns Hopkins. Quite proud of that. I think the combination of an atmospheric scientist and an environmental scientist is just one of those things that we need right now in this planet as we have to tackle some of the challenges that are ahead. We'll talk today about some of the top climate hazards that we're facing: heat, precipitation, sea level rise, what's ahead, and then a personal perspective. So let's dig right in, and we'll take Tampa as an example here. Now, obviously, you know, you think about Florida, and one of the first things you think about when you think about weather hazards is storms, tropical storms and hurricanes. And, you know, the threat today versus the threat in 2050 is not all that much higher, but it is slightly higher. And we'll discuss about why that is. Sea level rise, however, the threat for that is increasing rapidly as the rate of sea level rise is increasing in Florida and around the world. Ocean acidification, a big problem along the coast. It's you know, killing coral and many of the other organisms that require shells for living as well. Heat waves are increasing, and we're seeing significant warming. Now, as you look at this, it's a normal distribution, right? A Gaussian distribution for those geeks out there. And what I'm showing you is the normal distribution of temperatures, average temperatures. And the problem with this normal distribution is that it is shifting right due to global warming, due to climate change. We are seeing not just our average temperatures, the frequent temperatures that we get day in and day out shift, but notice the tail ends of this distribution. The ones on the left showing where, yeah, I mean, sometimes it does get cold in Florida. We do get frost and freeze warnings every once in a while, but less so today because cold and extreme cold events are becoming less frequent as this entire curve is shifting to a warmer average on the right. And on the other hand, we're seeing hotter days more frequently. This year in particular has been extremely hot in southern Florida in particular, and extreme heat is just something that's really rearing its head with a lot more frequency. Just to give you an example, in South Florida, we set the record for the earliest, hottest temperature ever recorded. We've done that 4 times already this year for the city of Miami. And across the state, I mean, pick your city. There on the legend on the upper right, and look at the historical average number of days per year in which the heat index, which is the combination of temperature and humidity, has reached 100 degrees or hotter. And we're talking maybe about 20 days a year on average or so, maybe a little bit more in Tampa and a little bit less in Pensacola. But then if we go on business as usual towards the middle of this century and take no action to mitigate climate change, we're going to, quintuple that amount. And we go towards late century and, it could be what, 7 times or 8 times that amount of 100+ degree days across our state. So that is leading to, and if you look at this chart and you try to fit, think of a linear regression here, you try to fit a best fit line to this bar graph, and it shows that we are getting, on average, more heat-related hospitalizations in our state. Probably the first thing you think about this, when you think about this, is, the kid in football practice, right, wearing the gear, practicing in the heat of Florida, and possibly having a heat stroke or something along those lines. But listen, this can also happen to farm workers. It can happen to construction workers. It can happen to anybody that has to work outside in what's becoming an increasingly dangerous heat here in the state of Florida. How about rainfall? Well, the signal is weak. These are projections towards the end of the century now of what you might expect in terms of rainfall trends in the state of Florida, and it shows that they should be slightly higher. I'll also highlight the fact that for a good portion of the Caribbean, and this is really important for the Caribbean nations, it's a pretty clear signal that it's going to be drier across a good portion of the Caribbean islands. And many of these islands depend on tropical cyclones to bring them the rain. We're going to be talking about those in just a second, because you'll see that there's no clear signal as to whether we're going to get more tropical cyclones or less tropical cyclones in a warmer world. Now, this is very relevant today. Now, if you're sitting in Miami-Dade County right now, we are getting a ridiculous deluge that started Saturday night and was particularly strong Sunday and Memorial Day. And then today, we've doubled the amount of rain that we saw either on Sunday or Monday. So for example, just in the last 2 hours, Miami International Airport has had more than 6 1/3 inches of rain, just in the last 2 hours. And that brings this event total, since we started to see this event unfold, to greater than 14 inches of rain since Saturday night through today at Miami International Airport. So as you look at this graphic, you'll see that we're getting more of the heaviest precipitation events. They're happening more often. So southeastern US, 27% increase. Northeastern US, 55% increase. The Midwest, 42% increase in the heaviest precipitation events. The top 1% of the events are happening with that greater frequency in those locations. Why would that be? Well, a warmer atmosphere due to climate change can hold more moisture in it. So when it rains harder, and we end up with those situations. Let's talk hurricanes, and this is a particularly fascinating subject, because of course we are quite concerned about hurricanes here in the state. And if you've ever lived through a major hurricane, you are one of the people that are watching this tonight and saying, yes, I count myself as a person that every time hurricane season comes around, I am quite concerned. Now, if you haven't lived through a major hurricane, if you haven't actually survived the core of a major hurricane, you might be a little bit more dismissive. And that's human nature. I'm not calling you out, I'm not blaming you. It's human nature to try to be more optimistic and not worry about the worst case scenarios. But sometimes the worst does happen. And many communities, whether it's Southern Florida and Hurricane Andrew, or the Florida Keys and Hurricane Irma, or Puerto Rico and Hurricane Maria, have had to face the worst of hurricanes. And we're seeing the worst of hurricanes more often due to global warming. So here are just some of the records that I can enumerate for you just in recent years, just since 2017. So Dorian, which had us quite worried here in Florida, it attained 185 mile an hour sustained winds outside of the tropics. In other words, north of 23.5 degrees north latitude, outside of the Tropic of Cancer. And that is the highest wind speed ever recorded for a hurricane outside of the tropical belt. It is the strongest system to ever strike the Bahamas, and tied for the strongest one in the Atlantic Basin with the 1935 Great Labor Day hurricane that struck the Florida Keys. What other records can I tell you about? How about Lorenzo, also last year? The first time we've seen a Cat 5 hurricane develop in that part of the Atlantic Ocean so far off to the east. In other words, closer to Europe and Africa than to America, okay? Pablo as well, the easternmost hurricane to ever be located. Again, I'm talking things that are closer to the Iberian Peninsula than to us, okay? Harvey, Florence, both US mainland hurricanes, Lane, which I believe was a Hawaiian hurricane, and Barry, all setting rainfall records for the most rainfall ever brought by a tropical cyclone. There's another record for easternmost hurricanes, Ophelia in 17. Hurricane Irma scared everyone. Why? Because it set the world record as the longest continuous Category 5 hurricane. Sustaining that intensity for such a long period of time, in this case 4 days, is just not something we'd ever seen. And finally, 2017, there's an index called accumulated cyclone energy. It combines the longevity of a storm with its intensity to create this index. And that month, September 2017, in the Atlantic, is the most accumulated cyclone energy ever recorded in any tropical basin around the world, including where typhoons form over there in the Western Pacific, and they get so many of them. Well, now we've got the Pacific beat as well, because the Atlantic set a new world record for just the ACE index in 2017. Just in the last 2 weeks, there was a paper published showing statistically significant increase in the proportion of tropical cyclones around the planet that are reaching Category 3, 4, and 5 intensity. Now, you look at this trend line here, and you look at this is around the entire planet. This is just looking at Category 4 and 5. You see the source there, Tom Knudsen from NOAA's GFDL lab up there in Princeton. And what we're seeing is not necessarily more tropical storms and more typhoons and hurricanes. What we're seeing is that a greater percentage of those are reaching these very catastrophic levels of Category 3, 4, and 5 intensity. What's happening is you're basically changing the speed limit for hurricanes. The physics of the atmosphere is changing because of the fact that it's a warmer atmosphere and a warmer ocean beneath, because we're warming the oceans as well. So under those conditions, the top speeds that you can attain in terms of highest sustained wind speed in a hurricane are increasing. Now, it's not by a lot. It's by about 7%. It doesn't sound like a lot, but when you're talking about wind speeds close to sustained 200 miles an hour, which would be the theoretical upper limit for sustained winds in a tropical cyclone, and you add 7% to that, and we're talking, 210 or 215, 214 to be precise. And that makes a big difference, because an extra 14 miles per hour of sustained wind means that you've got gusts that can be 30 to 50% higher than that extra 14 miles per hour. So now you're talking about wind gusts that can easily attain to 30 to 40, 250 miles per hour, which is tornado territory. And that's why, Maria did what it did in Puerto Rico. Not just to the power grid, which, clearly was not a modern power grid in Puerto Rico. But I mean, some of the structural damage seen down there from wind was just astounding. And that was a borderline Category 5 hurricane. So now that I'm talking about Maria in Puerto Rico, let's talk about this. And I know this is a complicated chart, but I'm going to try my best to explain what you're looking at here. So right there, it says return period of tropical cyclones within 150 kilometers of 17 north and 64 west. Yes, science. It's a little high powered here, but 17 north and 64 west is a location on the map just south of St. Croix in the US Virgin Islands. Basically, any hurricane that goes to Puerto Rico is near or just south of St. Croix on its final approach to Puerto Rico. Okay, it happened with Hurricane Hugo in 1989, with Hurricane George in 1998, and again with Hurricane Maria in 2017. So basically, we're talking about a storm that at the time was a Cat 5 at that location. And now let's talk about the return period. What does return period mean? It means how often, on average, can I expect a hurricane of that intensity with those characteristics to be located within that distance of that point on the map, so within 150 kilometers of south of St. Croix. If you look at the dots, the blue dots represent the return period at the end of the 20th century, so right up to the year 2000. And you might expect the return period if you, and I wonder if you can see my cursor, maybe you can. You can look at the return period here for a hurricane with winds sustained at 150 knots. 150 knots is approximately, let's see, plus 15%, that's 15, that's close to 170 mile an hour sustained winds, okay? The return period might be once every 200 years. This is a logarithmic chart, okay? So it goes by order of magnitude here, 1 to 10 to 100 to 1,000 to 10,000. So when I'm going across here, I'm talking about once every 200-year event. Well, I went and visited Kerry Emanuel, a renowned climate scientist at MIT. And his team and him are working on these projections, where based on what they're seeing, they're projecting that an event like Maria, instead of happening on average once every 200 years, would happen on average once every 20 years. So as we think about that, whether it's Puerto Rico or whether it's Miami, because Miami will someday get a Cat 4 and or a Cat 5, just like it did in 1926. I mean, it's just a matter of time before that happens again, or for that matter, West Palm Beach, okay? What happens in a society when you get a catastrophe happening instead of every 100 years, you get a catastrophe happening every 20 years or 25 years? I mean, is it possible to build in a resilient enough way to withstand that? What about the economy? You know, would people flee? And if they don't, how do you build your home strong enough to withstand something like this? Or how do you take these property loss hits with such great frequency? I think it brings up a lot of interesting questions in terms of what some of these extreme events could potentially be if we don't slow down this climate change train that, yes, already left the station, but needs to be slowed down, you know, at least until we can figure out a way to reverse it. We'll talk about that in just a second. Okay, so heat, rainfall, hurricanes, and now let's talk sea level rise, which in the case of southeastern Florida, particularly from Broward County south to Miami and the Florida Keys, is down the road an existential threat, okay? First, the obvious, right? With higher sea levels, the storm surges that hurricanes can bring have an ability to penetrate further inland because they're deeper, because we've already added the background increase of higher ocean due to sea level rise. I like to use this timeline. I don't know if you guys recall, maybe 3-4 years ago, there was a viral picture of an octopus that was found alive in a Miami Beach parking garage. Some of the buildings in Miami Beach, you kind of go down into the parking garage, and it was king tide season. And this octopus apparently came up right through the drainage and was just sitting there in a few inches of water. It's not like it was swimming, okay, but it was a few inches of water, of salt water, where this octopus was located. And I would classify that as a novelty, especially for those not living in that building, where certainly it was a nuisance. But for those outside of Miami Beach, for those outside of that building in particular, oh, wow, you know, an octopus in a Miami Beach parking garage, this is a novelty. Well, now here's the issue. These novelties are happening with such great frequency that they're becoming more and more of a nuisance for folks that not just live in Miami Beach, but those that live in Fort Lauderdale, and those that live in Coconut Grove, and those that live in Edgewater, which is a Miami neighborhood, or those that live in Coral Gables, you know, Hollywood, and many other locations along or closer to the coast of Broward and Miami-Dade counties. And it's becoming such a nuisance that it's starting to bleed into a lifestyle issue, because we're getting so many days a year now of sunny day saltwater floods brought on by, yes, the astronomical tide, but the tide is much higher now, that high tide, due to sea level rise. And it's really starting to affect lifestyles. Perhaps you've seen pictures of folks not being able, you know, the only way they can walk in and out of their condos or in Miami Beach is by wading in. Tourists in galoshes with carrying their suitcases, trying to get into those hotels on Washington Avenue or Ocean Drive because of sea level rise. This eventually, way before the water starts to lap at the first floors of the buildings on, say, Ocean Drive, is going to become a pocketbook issue. And, you know, there are, of course, artist renderings of, you know, South Beach buildings that have that water lapping up right, you know, to the half of the first floor of the building. But it's not going to take that for the economy and everybody's pocketbooks to be hit down here in Southern Florida. The reason for that is, you know, the insurance, first and foremost. The National Flood Insurance Program is already bankrupt because they've had to outlay so much money due to the increasing amounts of flooding events that we're seeing. And yes, granted, there's more people in harm's way. There's been, you know, there's been population increase. There's been more urbanization. And yes, a lot of these things have been built in floodplains. But at the same time, with increasing sea levels and increasing rainfall intensity, we're seeing more of these happen. And therefore, the NFIP, National Flood Insurance Program, needs attention. And Congress is looking at it. And it's a very unpopular issue. They don't know how to handle it. They know their constituents are going to be quite upset when they finally figure out that they cannot continue to subsidize at unreasonable rates, really, rates that are not reflective of the risk, the flooding that goes on in this country. And particularly the saltwater flooding that could go on here in Southern Florida. So that's one pocketbook issue. The other pocketbook issue is, you know, the reinsurers and the banks, they're aware of what's going on. I mean, they don't care about all the noise that might be coming from, you know, science-denying politicians. They're looking at their bottom line, and they're looking at the science. And looking at the bottom line and looking at the science and looking at their projections from the best scientists out there, they know that this issue of sea level rise could very well become one where they are forced to no longer have mortgages that go out 30 years because they don't know where the value of that property is going to be 30 years down the line. Because in 30 years, we could have another 2 feet of sea level, and therefore that home could be inaccessible, or the value of the property would be decreased because getting to the home is so difficult, and you've got 150 days a year of flooding going on with salt water or numerous other things. And then, of course, down the road, we talk about the existential threat, right? Having to abandon parts of South Florida. Now, don't worry, I'm not throwing the R word, in this case means retreat, out there loosely. But I will tell you this, just in the last 12 months, for the first time, we have started to see political appointees, like those in the Florida Keys, start to actually acknowledge the fact that there are parts of their constituents' infrastructure, the ones that everybody pays the taxes for, that cannot be saved from sea level rise. So they are actually picking and choosing in the Florida Keys which roads are worth elevating and which ones will just have to be abandoned due to sea level rise. And by the way, the Florida Keys are the worst place to be, because it'll only take a half a meter of flooding, that's less than 2 feet, 1.5 feet of flooding, to basically inundate 70% of the Florida Keys. Okay, so for them, this is an existential issue much before it is for anybody else. There's buyouts going on down there where properties are being bought out so that people will never build there again because of the propensity for flooding. There's other issues too. Saltwater intrusion into drinking wells is one of them. Yes, deeper and widespread rain-induced floods like we're seeing right now in Miami, with the water table being higher, pushed up by the encroaching seas, the water doesn't have as much room to drain into or percolate into the ground, and we end up with faster floods across South Florida. Yes, there are ecosystem changes in the Everglades. Ghost forests are developing along the coastlines of the Everglades. This is where salt water comes in and kills the trees that depend on the fresh water. So what we need in the Everglades is increased freshwater levels. That's a whole other talk. But we need the Everglades to be restored to be able to keep that at bay. All right. I guess I'm going to race through these last ones because I'm not sure how I'm doing on time. But just to show you here, the rate of sea level rise is the fastest it's been over the last 2,000 years. There are many projections, okay? Science is messy. We're not sure how quickly the water is going to melt off of Greenland on that ice cap. We're not sure what's happening in terms of how quickly the West Antarctic ice sheet it might collapse or not collapse. And because there's uncertainty in this, the projections for sea level rise between now and 2050 and the year 2100 are varied. They're as bad as 8 feet by 2100 and as not bad as 2 feet by 2100. But the consensus is, and the Southeast Florida Climate Compact has decided that the best consensus estimate of how much we can expect is that by the year 2060, we're going to get another 2 feet on top of the 5 or 6 inches we've already had of late. So this is leading to observed high tide flooding in many more days a year than what we used to have. This is one particular location here in Georgia, and there you see the bar graph at the bottom. This is the observed days of high tide flooding, and then you see the projections going down towards the next decade or towards the middle of the century or end of the century. And depending on how quickly sea level rises, that's how many more days of flooding we're going to have a year. In the extreme case, by the year 2050, they'd be flooded year round, right? So hopefully it's not going to be extreme. But we can't rule it out because there's been much faster rates of sea level rise in the past, even without the added element of human-induced global warming. I'm just going to skip this one. There's your example of a storm surge. You add 2 feet of storm surge. This is a map of Miami. There's Miami Beach on the lower right. Port Miami, basically also on the lower right, closer to the center. The coast of Miami proper. and Miami River there in the bottom of the screen. So you can see how much further the storm surge would, and deeper as well, the storm surge would penetrate with an added 2 feet of sea level rise, which again, we're talking possibly by the middle of the century, 2050 or 2060. Okay. Hopefully you've had a couple of those beers. This is science on tap, right? I think a lot of this material requires a beer or two. And I guess you can't see the top of the screen here, but what it says is this a silent spring moment? If you're familiar with Rachel Carson's book from the 1960s, where she detailed the damage that was being done by pesticides, particularly DDT. DDT wasn't just killing the pests on the crops, it was killing many other things, including birds. Amongst the birds, the bald eagles. And this book was a sensation. And part of the reason it was a sensation is because a lot of bad environmental damage was really coming to the forefront in the 1960s and close to 1970. Rivers were catching on fire up in near Cleveland. There was a terrible oil spill near Santa Barbara, California. The DDT issue, the smog and the pollution across the cities and in our local waterways was just off the charts nasty. And people were really starting to take notice of all this. And between that and Rachel Carson's book, Silent Spring, there was a big push to make our political leaders aware that people were really concerned about this. Concerned and upset and worried about their children and worried about, the environment that surrounded them in the places where they lived and the landscapes and everything else. And that call to action to our politicians and our leaders really did lead to an environmental revolution, an environmental regulation revolution here in the US. The National Environmental Protection Act came about around that time, near 1970. The Clean Air Act was a 1970s product. The Clean Water Act. All these things happened, and a lot of them happened during the Nixon administration. So, this is not a Republican issue. This is not a Democratic issue. This is a people issue. It's our health. It's the health of our children in terms of the environment. And then it's also the well-being, the health of our children when we're thinking about global warming and climate change, because I already showed you where we're headed if we don't stop it, right? We have to find a way to slow down this train so that those extremes that I showed you won't reach that level, so that we can keep it either where we're at right now, or hopefully slow it down or even reverse it to the point where we can, go back to normal. Because these extreme weather events that we're seeing are indeed a consequence of a warmer atmosphere and the warming surrounding oceans. Now, these movements oftentimes start local and then go national. In Florida, because of the blue-green algae and the red tide, you want to think about something that turned the 2018 election in Florida. It's when Ron DeSantis pivoted to environment. As soon as he pivoted to environment, that helped him win that election because people were extremely concerned about the environment. So in Florida, he certainly talked a game about trying to help the environment. That he's backed that up with some significant budget, of course, with the legislature's help, budgets to restore the Everglades, budgets to try to help the environment. Those of you out there, you can throw some things at me and say, call me okay, boomer, or call that out because I'm saying that the youth is woke, but indeed they are. And these, Friday climate strikes for the future, and people like Greta Thunberg, and here in the US, we've got other leaders as well that are maybe not as well known as she is, but they're also helping lead the way. The youth is extremely concerned about this. They're extremely concerned about the climatic changes that are going on and what type of a planet we, the baby boomers, and previous generations have left for them. And they are going to drive the change. They're coming into voting age now. And well, actually, many of them are already. Some of the Gen Zers already are. The millennials, certainly all of them are. But there's more Gen Zers coming. And this is going to drive change down the road. So I think this could be a silent spring moment. I know we've got the pandemic going on right now, but the climate issue has not gone away. And I've seen already some updated surveys that indicate that people are just still as concerned about the climate crisis right now, despite what's going on with the pandemic. And Americans' views on climate have evolved quite a bit as they've learned more about it, as they've seen more of these extreme weather events happen. And that too is going to lead to the political pressure that's needed to be able to right this ship. So hopefully I've left enough time for questions and trivia and everything else that's going on, but that is my presentation, and I will stop sharing the screen right now.
John, thank you so much. I'm excited to transition over to our question and answer session. Our first question for tonight comes from Deborah, who asks, do you find that most meteorologists and newscasters see the science of climate change as real?
Yes, they do. Now, granted, 15 or 20 years ago, there was a bit of a challenge with that where, half of our broadcast meteorologists were quite skeptical about the science of climate change. Oopsie. Sorry about that. Quite skeptical about the science of climate change, but the American Meteorological Society recognized that there was a bit of a gap in the knowledge of the broadcast meteorologists. So the American Meteorological Society started some workshops and short courses to bring these meteorologists up to speed. And what we've seen now is that basically 90% of broadcast meteorologists out there are not just accepting of the science, but many are starting to communicate on it as well. I've certainly done it for many years. I think I'm known somewhat for being one that communicates on climate quite often, but many others are doing so too.
John, our next question comes from Stephanie, who asks, what are cities along Florida's coastlines doing to mitigate sea level rise and storm surge issues? She also asks, how can residents prepare as storms become stronger?
Yeah, I mean, there's a lot being done. We need more natural areas. We need more mangroves along the coast. That helps tamper down the storm surges as they come in. Some cities are creating natural basins where the water can accumulate instead of being on the streets. And these are natural green spaces where water can accumulate when it's excessive. Also, you've probably heard about what's going on in Miami Beach. They've invested $500 million in pumps that pump out the seawater and also elevating roadways around the city of Miami Beach. But, I see some of these things as Band-Aids. Yeah, they're keeping some neighborhoods dry right now, but if sea level rise continues to accelerate, it's going to be very difficult down the road. There's another new project from the Army Corps of Engineers. It's kind of a crazy project. They're going to build these walls all along the southeast coast of Miami-Dade County in particular. And these doors will have, these walls will have big doors that can close for a storm surge. Well, I think they might help for storm surges, but the problem with sea level rise is that what lies beneath us here is porous limestone. So unlike the Netherlands, right, where they live below sea level and they've been able to build these dikes to be able to keep the seawater out, or for that matter, New Orleans, all right, their bedrock underneath is not porous. And once they build a wall or a dike, they can keep the water out. We can't do that here in South Florida because the water will just percolate up through the limestone. That's why sea level rise is such a threat to South Florida, and that's why I really highlighted it in this presentation.
Our next question is going to come from Samantha, who asks, what are some of the best things that you can tell a climate denier?
Yeah, I think one of the best ways to approach that is you need to find common ground. And common ground, it could be something as simple as, what if this denier or even skeptic, right? What if this person likes to, is a jogger or maybe a cyclist, likes to do things outdoors, right? Uh, well, maybe you can find some common ground there by pointing out the fact that, heat indices in excess of 105 degrees are going to happen more often. And did you know that it's dangerous to exercise under those conditions because you could suffer a heat stroke? You could end up in the hospital. Are you aware that that's already happening? Regardless of what happens in the future, we've already seen an increase in 105-degree heat index days in many cities in the US. That would be one way to relate to them. Another way, of course, is thinking about their children, thinking about their grandchildren. So you need to find common ground. And that's the best way to break the ice and find a way to make them think about this problem without, shutting themselves into their bubble.
Chris is wondering, how do you feel broadcasters can more effectively communicate about climate matters and long-term impacts, as opposed to a typical viewer who's just used to hearing about short-term weather?
Yeah, I mean, there are so many opportunities these days. That's part of the reason that I've been able to increase the number of days that I talk climate during my weather segment, because I mean, just like this big flood that's going on in Miami-Dade County right as we speak, right as we're presenting this, right? These events that used to happen once every 50 years or once every 100 years in terms of the return period, now they're happening every 3, 4, or 5 years. I mean, I don't have to go back too far to find another 15-inch rain in 3-day event for Miami, whereas it used to be something much less frequent. So what do? I get on TV, and I'm not telling people on TV that, hey, this was caused by climate change. No, that would be incorrect. It would be scientifically incorrect to say that this wasn't caused by climate change. However, getting more excessive rainfall events more frequently is consistent with what you would expect in a warming world. That I can communicate, and that I do quite often.
Our next question comes from Monica, who asks, what do you see as the role of educators to inform the public or students about climate change? And what do you suggest that they tell parents who think that elementary school grades are too young to start talking about climate change?
Yeah, it is extremely important. This country faces many challenges in terms of the education, because education, of course, is controlled at the local level. And there are many counties in this country where, teaching science and scientific knowledge and facts is not allowed. Or if a student gets the wrong question, they're allowed to just write a note to the teacher and say, well, my religious beliefs say that, this isn't so, that the earth isn't, 3.5 billion years old. And therefore, you can't mark me wrong for this answer, right? So these are some of the challenges that we face in this country. It is extremely important to start early and to communicate this, because listen, I mean, it's just like me on TV. I serve as the newsroom's scientist. Why? Because, well, I happen to be a meteorologist. I'm trained in science. Everybody else is trained in journalism, so they don't understand science as well. So I'm considered to be the station scientist, and I have to know about astronomy. I have to know about volcanoes. I have to know about earthquakes. Well, I mean, if I have to know about all those things, I think, kids need to know that too. It forms your basis of general knowledge to make you a well-rounded, educated person. And climate is included in that. Climate is changing, and it's important for people to realize that it's not a natural change that's going on right now, but it's driven by the industrialization of the planet.
All right, John, we have time for just a few more questions. Our next one comes from Jeff, who says, what are potential irreversible climate change effects on the ecosystem that might be more insidiously led to catastrophic ecological collapse? And what might be more likely scenarios?
Well, I mean, I think Jeff probably knows, since he seems to be asking this question from a place of knowledge already, that we are living through the sixth great extinction on this planet, and it's greatly being driven by us, by our expanding footprint. I mean, you know, you talk about this pandemic. It is our expanding footprint that led to this zoonotic disease, like some of the others that we're starting to see, because we are, you know, mixing with wildlife a lot more often than what we used to, because we're encroaching upon their territory a lot more often than we used to. So in terms of some of these things that we're causing, in terms of our expanding footprint, if you on top of that add a rapidly changing climate, it's going to make a lot of species not be able to adjust to the changes. For example, out west, we have some species that are having to climb in elevation, climbing up the Rockies, climbing up the Sierras, trying to find the habitat and the climate that they're accustomed to, that they can thrive at, right? So that they can be best fit to be able to reproduce and continue down the road and survive. Well, they're running out of mountain, okay? Because the temperatures are warming too quickly. So that's just one example of some of these changes that are going on and why it's so important to consider biodiversity as well when we're talking about a sustainable Earth.
All right, John, and one more question. This question comes from Lucy, and her question is, what gives you hope for the state of Florida?
Yeah, I mean, I think for the state of Florida, an awareness of what's going on. I often tell people here in Southern Florida, listen, it's not a matter of running away. You just need to plan properly. You know, be aware of what's coming. Act smartly. Maybe you shouldn't be considering that your home is something that your grandchildren are going to be able to inherit based on where it's located here in South Florida. Fine. Maybe you can make a killing on the selling of your home sooner than later. Just incorporate that into your planning so it doesn't have to be all doom and gloom. Just be aware of what the coming reality is. In addition to that, in terms of hope, well, some adaptation, some mitigation, but I think the most important hope that we can have, really at the local, state, and national level, is we need collective action. We need nations to step up. And just like the 2015 Paris Accord was signed, which for all its faults, okay, is the one time that all the nations on Earth agreed to find ways to mitigate the rapidly changing climate. Well, I'm sure that as soon as we have the leadership that is going to allow nations to come together again, much like they did in 2015, we're going to find new agreements, new ways to go forward. And between that and emerging technologies, you know, whether it's geoengineering or other ways to burn less fossil fuels, transition away from carbon, and find ways to live on a sustainable planet in a regenerative economy, I think there's reason for hope.
John, I cannot thank you enough for this amazing presentation and teaching us more about climate change and for all the work that you do.